So today is day 5, I think. Pretty sure it's day 5. And today we're going to talk about sections 1.4 and hopefully get done with 1.5 so that you can finish the homework, which I extended the due date of the homework to this Thursday since I didn't cover all the material. So if you've been keeping up with the homework, after today you should be able to do like the last couple of problems, okay? So you just need to do those from before Thursday at midnight. I'll remind you again on Thursday's class that the homework is due that night. Okay, and what else? Office hours today from 3 to 4:30 as usual. So the way you do that is you just go to Blackboard, you click on the Microsoft Teams link and get into the Microsoft Teams and we'll do it virtually, okay? So you'll see my iPad screen and you can ask me about any homework questions that you have or anything like that. SI sessions. Has anybody been to an SI session yet? Fantastic. How was it?
I would say that it was pretty chill. Just went over problems that we just extra practice for the additional problems.
Okay, that sounds like a 5-star review to me. It was, quote, pretty chill. You just went over homework problems. And yeah, so if you want to, do the homework in a collaborative setting, SI sessions and office hours are the way to go. It's always more fun with other people and you learn more anyway. So I highly recommend that you do those. Let's see, what else? We're going to have a quiz this Thursday. So the quiz is going to be over sections 1.2 through 1.5. So let me remind you all, by the way, that the questions for the quiz come from the extra problems, okay? So one of the quiz questions will come from these sections at the end of each section where I have extra problems, okay? So if you practice those at home, okay, from the relevant sections, then you will know how to do at least one of the 2 quiz questions, okay? So one question gets pulled from the extra problems, one question I'll make up, okay? So I highly recommend that you practice those extra problems so that you can do well on the quiz, okay? So again, that quiz is going to be over sections 1.2 to section 1.5, which we'll finish today, okay? So any questions about the quiz? All right. Also, I've had a bunch of people emailing me that they need to miss class because they're sick or because they are waiting on a COVID test or because their roommate's mom's brother got it and they want to get a test before they come to class. That's totally fine. Just shoot me an email and let me know, okay? If you have any concern whatsoever about COVID, just email me, get tested, come back to class once you know that you don't have COVID. Sound good? All right. Yeah, if there's a quiz or something that you miss because of quarantine or something like that, I will let you retake the quiz, okay? So don't worry about that. All right. Any administrative questions before we start class today? Okay, how about content? Any content questions before we start class today? I don't do extra credit on the quizzes, nor do I do extra credit in any other capacity. The only extra credit option, I guess, is I will drop your 2 lowest quizzes and I will drop your 2 lowest homework scores. Okay? So if you miss a quiz for an unexcused absence or if you forget to do your homework 1 week, okay, it's not going to be an issue. You can do that twice on quizzes and on homeworks without incurring a grade penalty. All right? Good question. Any other questions? All right, then let's start. I started this, right? Okay. So last time I think I was just sort of getting into section 1.4, and today we're going to try to finish section 1.4 and 1.5. So a bit of a tall order, but I think we can do it. So let me just remind us where we were. So we discussed 3 new functions, okay? So this is a business class, so we're always going to be talking about cost and revenue and profit and those sorts of things, because that's apparently supposed to be relevant to your career. So the cost function, okay, is going to relate the total cost to the production of a certain number of items or services, okay, goods or services. So Q here is our quantity of goods, and C is going to be our cost, okay? So Q for quantity, C for cost. Likewise, revenue is going to give the total dollar amount for which Q items may be sold, okay? So big difference that we highlighted last time was the difference between the revenue and the profit. Can someone elucidate that for me briefly, what that difference is? One more time. Shania.
Revenue is how much you make in sales before the cost.
Exactly. Revenue is how much you make from your sales before you deduct your costs. Okay? So just because I have a big revenue doesn't necessarily mean I have a big profit, right? And in the end, most business interests, we're interested in the profit, right? Okay? Having great revenue is great, but we also want to keep our costs low so that the difference between our revenue and our costs is big. Okay? So that's our profit. Okay, and then another concept that we introduced was the idea of marginal profit and marginal revenue and marginal cost, okay? And the way that I've described those so far is just that they're the rate of change of these functions. Okay, so we haven't, strictly speaking, fully fleshed out rate of change. Oh, I better plug my MacBook in. We haven't fully fleshed out rate of change, except for in the case of linear functions, right? What is the rate of change of a linear function? Can anyone tell me? It's the slope, exactly. So the slope of a linear function tells us how that function is changing, okay? So if we have a linear profit function, then the marginal profit is the slope of that profit function, okay? And later on, we'll kind of generalize this idea of slope using what we call derivatives, okay? Or instantaneous rate of change. All right. Any questions on cost, revenue, profit, and marginal cost, revenue, profit? Okay, great. So, oh yeah. One more thing I wanted to talk about, I didn't quite have enough time to do this last time, was this example here, goods are us. Okay, it has a cost formula which is given by 9876 plus 0.5 Q. Okay, and that's how much it costs to produce Q goods. So it's kind of intrinsic in the name here, but we've got a fixed cost and we've got a variable cost. So if you just think about what the word fixed means, that means, stable, stationary, and variable means changing, right? So in terms of our cost function, these are the names that we give to costs which are going to be constant, okay, versus costs which are going to increase based on the number of goods that we produce, okay? So fixed costs occur regardless of Q, and variable costs typically rise with Q. Okay, so we want to think about, well, if I increase my Q from 1 to 2, how much does the cost go up? In this case, it goes up by 0.5, right? Okay, so variable costs is maybe kind of code for marginal costs. Marginal costs. Okay, so this is just some lingo. Okay. Okay, so let's think for a second about this example. So Goods R Us is a company. They're producing some amount of a good, and that's costing them some amount of money. Okay, so in this class we always have these word problems. We're trying to interpret them. Who can give me a potential interpretation of the fixed cost in this case? Okay, so our fixed cost in this case is $9,876, I guess. So who can give me an example of a fixed cost for a company like Goods R Us? Rent? Yeah, rent is good, especially if the cost function is only for a specific month. One thing that we should be a little bit careful about is, if we talk about rent, is that you do typically pay it on a month-to-month basis, right? So that will increase over time. But if we say that C of Q is simply our cost for goods this month, then rent would be a great example, okay? So something that's a stationary cost that isn't gonna go up in the context of our problem, okay? So one that might be even more stationary than rent could be maybe the cost of, I don't know, the cost of your factory or something like that. One-time payment to get your business up and running, right? Okay, how about the 0.5, 0.5? What could that possibly represent in terms of this problem? Brandon?
Cost of production.
Yeah, cost of production, but what exactly are we producing and for how much money, right? In this case, it costs 50 cents to do what? Whoops. Yeah, produce one good, right? So if Goods R Us is selling toys, for example, then this would mean that, okay, it costs the company 50 cents per toy to make, right? Not to sell. Okay. So 9876, call that rent for the month. And 0.50 cents, okay, is cost per good. Like, for example, material costs. For example, okay, doesn't necessarily have to be that. All right, any questions about this example, problem number 1? Just some more lingo. Okay, if not, then I'm going to move on. Let's see, was I going to do these ones? Okay, I wasn't going to do these ones, but I think we're going to go over this one. Okay, let's do this one together. So Ted wants to start up a lawn care business. Okay, so it's going to cost $12,000 to buy the lawn equipment. So what do we think about that first statement? It costs $12,000 to buy all the lawn equipment. Fixed or variable cost? Fixed, right? Because I only have to, not me, but Ted only has to buy his lawn equipment once, right? And then he's got it. Until it breaks, anyway. Okay, so then he will need an average of $4 per job in gas and maintenance. What do we think about that cost? That's our variable cost, right? That's per lawn that he mows, right? Okay, or per job. All right. What do we think about charging $50 per job? How can we interpret that? It is variable in some sense, right? It's per job. But this is our revenue. Yeah, right? This is what we're charging. Okay? So another word that we could use instead of variable revenue, what's that other word that we used for?
Marginal?
Yeah, marginal, okay? So that could be our marginal revenue. Okay, so $12,000 fixed cost. $4 per job, that's our variable cost, or our marginal cost. And then $50 per job, that's our marginal revenue. Okay, so find R of Q and C of Q. Well, R of Q Is there a fixed revenue for this problem? No. Why don't we have a fixed revenue?
So we're only looking at when you start in per job, not the cost involved.
Yeah, exactly. If you don't mow any lawns, you don't earn any money. So in this case, our fixed revenue is 0. If we mow 0 lawns, we earn 0 money, okay? So we just don't write our fixed revenue, so to speak. Okay? What could be an example of a fixed revenue that you might get, by the way? Yeah.
I guess like if you're like a landlord, like your rent's like your tenant payments.
Well, of course, the good in that case, if you're a landlord, the good you're selling is one good is basically the privilege of living in the apartment for 1 month, right? So in that case, as the months go up, so too does the amount of money you earn, right? Can anybody think of something else that might be a little more stationary in terms of revenue?
Like end of year bonus.
End of year bonus could be
Minimum wage.
minimum wage. Again, that's per hour, right? We're looking for something that doesn't depend on how much you work.
Like a salary?
A salary is getting very close. I think one thing that we could think of in terms of marginal revenue, or not marginal revenue, in terms of a fixed revenue could be like, if you're a lawyer, you might charge a retainer, right? So you pay me $5,000, whatever, just to retain me, and then on top of that, for any hourly work I do, I charge a certain hourly rate. Make sense? That could be an example of a fixed revenue. Okay. That was a big aside. So in this case, what's our R of Q gonna be, do we think? If we're charging $50 per job, we've got 0 is our fixed revenue, and then plus what? Yeah, 50Q, $50 per job we do. So we can just call it 50Q. All right, and our cost? Well, our fixed cost, and we should add to our fixed cost our marginal cost, right? So we get $12,000 plus 4Q. Okay. So, let's move on to the next question. What is Tim's marginal revenue in this case?
$50 per job?
Very good. $50 per job. And one thing that I'll highlight, a common mistake that I sometimes see when people look at marginal revenue and they answer this question, they just say 50Q, right? But this isn't quite right, okay? Because what we're talking about when we say marginal revenue is really the rate of change of the revenue function, which in this case would be the slope of the revenue function, okay? So if I asked you what is the slope of that line, you wouldn't give me 50Q, you would just tell me 50. Okay, but if we make it in terms of the problem, we can add our units dollars per job if we want. Okay, so that's the marginal revenue, and then the marginal cost is 4, right? $4 per job. All right, how do I get the formula for pi of Q, the profit after completing Q jobs? Yeah, we just take our revenue minus our cost. Who was that? Who said that? Ah, thank you, Alyssa. Okay, so we just take pi of Q equals R of Q minus C of Q. But there is one thing I should be a little bit careful about here. When I plug in R of Q, I get 50Q, right? But when I subtract the costs, I should be careful to subtract the entire thing. Okay, this is my costs, and I should subtract all of it. So I'm going to subtract parentheses 12,000 plus 4Q. Okay, so a common mistake here would be to say I'm going to do minus 12,000 and then plus 4Q. That would be a common mistake. But in this case, you would actually be adding money per job with this plus 4Q. So we need to remember to subtract that, so we should distribute this minus sign over both pieces here. All right, so if we simplify this, we get, what, 46Q minus 12,000. So what's Tim's marginal profit? Yeah, $46, okay? It's the rate of change of this new function. So $46 per job. So that tells us that actually we can find out what the marginal profit is pretty easily. Marginal profit is just going to be equal to the marginal revenue minus the marginal costs, right? Okay, so remember up here we found 50 and 4. So 50 minus 4, we get 46. Last time I checked. Yep, question? All right. Now, this last part, let's think about for a second. You want to know, what is Ted's break-even quantity? Well, in terms of revenue, costs, profit, and these sorts of things, what does break-even quantity mean in terms of our revenue, cost, and profit? Adrian?
You would set the equation we just got to 0.
Yeah, so two ways we could do it. First of all, we could set our profit equal to 0. If our profit is 0, we didn't earn any money and we didn't lose any money. That means we broke even. So that's one option, is to set the profit equal to 0. And the second option is, well, if I don't earn any money and I don't lose any money, then my revenue and my costs were the same, right? So I could also take the revenue function and set it equal to the cost function. Two different ways of getting to the same place. So we'll use Adria's method. Well, break even, that just means pi of q is equal to 0. So we set pi of q equals 46 q minus 12,000. We set that equal to 0. We move 12,000 over to the other side. We got 46q is equal to 12,000. And we divide by 46, divide by 46. We get q is equal to, I don't know, whatever this number is. Okay? All right, how do we feel about problem number 2? This first example with revenue, cost, marginal cost, profit, and break-even quantities. Let's have some thumbs. Thumbs up if you're feeling good. Thumbs down if you're feeling not as good, and somewhere in the middle if you're somewhere in the middle. Okay, I think we can move on. If you're not as comfortable with it, come and talk to me after class and we'll chat for a minute. All right, so let's move on. I'm gonna skip this one. You can do this one at home. And we're gonna discuss something new now, which is supply and demand. And I am gonna preface this discussion by letting you all know that this is one of the more confusing things that we talk about in this class, for a specific reason, which I'll talk about in a minute. Okay, but let me just give you the definitions first. Okay? The supply curve for a given item relates the quantity Q, and I'm going to write a little s underneath here, okay, because we use QS for quantity which is referring to supply, and I'm going to use QD to refer to quantity which is referring to demand. Okay, the quantity QS of the item that manufacturers are willing to make according to the given price. Okay, so the supply curve works like this. The input is our P, our price P. Okay, so I say to the manufacturer, you can sell hamburgers for $5 per hamburger. Okay, and the manufacturers come back to me and they tell me, well, at that price point, I guess I'm willing to make 20,000 hamburgers per month. That would be a good way for me to do it and make good money. Okay? Of course, if I say that you can sell hamburgers for $10, do you think that the manufacturers are going to want to make more or less hamburgers? Well, the manufacturer stands to gain from the increased price at which you can sell hamburgers, right? Their manufacturing cost didn't change. The price here is referring to the price for which the item can be sold. Okay, so the given price P for which the item can be sold. Okay, so if the price for which hamburgers can be sold goes way up, and I'm a hamburger store, I want to make a lot more hamburgers because I stand to gain a much bigger amount of money by selling them if they're selling at a high price, okay? So the demand curve is similar, okay? The demand curve, okay, all of these words are the same, except they're going to relate what? The quantity QD of the item that consumers are willing to buy. According to the given price P for which the item can be sold. Okay? So, going back to our hamburger example, all right? If the price of hamburgers jumps up from $5 per hamburger to $10 per hamburger, what do you think is going to happen to consumer demand? It's going to drop, right? A very relevant example right now, right? The price of food right now in the United States is going up, which makes people want to buy it less, which makes people shop at restaurants less, which makes restaurants go out of business. Well, also we got the pandemic, which is affecting that as well. But this is the basic premise of supply and demand. Okay. One more equation that I want to just really quickly mention, okay? This may come up at some point later in the class, okay? Is this equation R equals P times QD. Okay, this comes up in this example later on, which you can do at home if you want. But what does this equation really mean? The revenue which I earn as a business person, if I'm operating under ideal circumstances, is the price per unit sold times the quantity of goods which consumers want to buy, right? Okay, so the thing is, if I raise the price of my object that I'm selling, okay, then the demand for that object goes down, right? And if I lower the price for the object that I'm selling, then the demand for my object goes up. Okay, so I want to find the perfect zone where I'm selling just the right amount of items at just the right price in order to make the most revenue, okay? For example. Okay, any questions about supply and demand so far? Yes, Brendan.
So does supply and demand also have, do they have a marginal cost?
We can certainly talk about the rate of change of a supply function or of a demand function. I'm not sure that we actually use the words marginal supply or marginal demand. I don't think we do. Let's check down here. Yeah, I don't think we really use those words to describe supply and demand. More likely we will use rate of change. Okay. Yeah, a lot of this stuff can be a little bit confusing because some of this marginal word, like why do we use the word marginal profit instead of just rate of change of the profit function, right? Well, it all stems from the fact that, well, long before mathematicians got their hands on money, other people were doing math about money, like economists. Okay, and economists did things in a weird way, which is why now mathematicians are forced to sort of present the mathematics of economics in this weird way that they invented it, even though it's not really maybe the best way of doing it. I know that sounds kind of nebulous, but let me give you a concrete example of something that the economists like majorly donked up. So let me discuss what is confusing about supply and demand. And this comes back to, there was a question from a student, it might have been you, Brendan, earlier in the semester who asked me, is the independent variable always on the horizontal axis? Was that you who asked that?
I think it was somebody else.
Someone else asked me whether the independent variable is always going to be on the horizontal axis. And I said yes, except for this one confusing thing we do. And this is that confusing thing. Okay, so what's confusing about supply and demand is graphs of supply and demand curves put the independent variable which, let me pull the class. What do we think is the independent variable for a function like QS of P? Yeah, it's the price, right? The independent variable is inside the parentheses. So in this case, the independent variable, which is price, on the vertical axis. Okay, so why is that confusing? That's confusing because our normal understanding of what a slope is gets totally flipped on its head. Okay, so under normal circumstances, we would think that this pink line has a steeper slope, and so its slope should be larger, right? But if our independent variable is on this axis, then actually what you can think of is you can think of this as being like the floor, and you're looking at everything sideways. And if this is the floor, then that's the sky. And you think about, well, which one of these is rising faster? If you think of this direction as being the sky, it's this blue curve, okay? So yes, I understand this is really confusing, and it's really the only time that you'll probably ever see an independent variable get put on that axis, unless you go on to become a mathematician. Then there are other times that you might see it. But this is probably the only time that you'll see it if this is your final math class for sure. So it's really confusing. But what you have to think about is, well, my run is on this axis, and my rise is on this axis. Okay, so if you think of 3 times P, that means for every increase 1 in P, the blue one goes up 1, 2, 3, right? But for the pink one, it's 2P, so every 1 increase in P, the pink line goes to the right 2 units. Okay, so that's why we get these different kind of pictures here. I know it's really confusing. Okay, any questions about that? All right, well, here's my promise to you. On an exam, or a quiz, I will not make you read or draw supply-demand graphs, just because it's so confusing, okay? It just never goes well. But I might ask you questions about supply and demand equations. Okay, so I might ask you a question like, what's the equilibrium price, or something like that. You'll tell me what it is based on the supply and demand functions, okay? But I won't make you manipulate the graphs in any meaningful way. Fair? Okay, so let me just give a quick example of supply, and then I really got to move on to exponential stuff. Okay, so the supply, we're doing problem 5 now. The supply curve for a given product is Q equals 600P, and the demand curve is given by Q equals 33,000 minus 500P. Okay. So this makes sense, by the way, if you think about our intercepts. Think about if the price is 0. If the price is 0, then the supply curve is going to be 0, right? If I can't make any money from selling something, I definitely don't want to sell it, right? And the demand curve, well, if the item is free, then people definitely want it, right? And as the price goes up, the amount that they want goes down. Okay, so this is all making sense in our head so far. Okay, and we take the price is somewhere between $0 and $60. Okay, so we want to know, at a price of $10, what quantity are consumers willing to buy? And what quantity are producers willing to supply? Okay, so if we take a look at these two equations, we have our QS is equal to 600P, and QD is equal to 33,000 minus 500P. And we're just going to take this price and plug it in, right? If we plug in 10, then we get QS is equal to 6,000, right? 600 times 10. And then QD is going to be equal to 33,000 minus 5,000, which is, I guess, 28,000. Okay, so in this particular situation, is there excess supply or excess demand? There's excess demand. What does that mean in terms of the problem? If there's excess demand.
You're like selling more than you're making? Is that right?
It's not that we're selling more than we're making. Okay, supply and demand is about how much people want to buy or want to sell an item. Is this a good market for sellers?
No.
No, right? And we can tell because sellers don't want to sell very much of the item. Okay, the price is too low, so it's not worth it for the manufacturers to sell that much. But on the other hand, the consumers say, hey, that's a great price. I want to buy a lot of that item. Okay, so that's the way we interpret it in terms of the problem. Okay, So next question, equilibrium price. Well, I think I can go ahead and ask the class, what do we think is going to help us to find the equilibrium price? Yeah, Shania?
Setting supply and demand equal to each other.
Yeah, the equilibrium price is going to be the price that's in that Goldilocks zone where the manufacturers want to make the same amount as the consumers want to buy, right? In theory, the invisible hand of the market drives things towards this equilibrium point, right? Okay, so what is the equilibrium price? Well, we just take 600p equals 33,000 minus 500p, and we solve this equation by adding 500p to both sides, right? So we get 1100p is equal to 33,000. Okay, and so we just divide both sides by 1100, and we get p is equal to 30, I think.
Yeah.
Right? 30 times 1100. Okay. So that's the equilibrium price. What's the equilibrium quantity, though? How do I figure out what the equilibrium quantity is? Sorry? Plug in 30 for P. Where? Here? If I plug it in here, I'll get 33,000 equals 33,000. Where should I plug in P?
For Q.
Yeah, in one of my QS or my QD. In this case, it doesn't matter because we should get the same number. That's the whole point of setting QS equal to QD. So we're going to back substitute, okay? So for this one, to find the equilibrium quantity, we take this guy and we're going to back substitute in here. So we get QS equals QD equals 600 times 30, which is 18,000, right? 3 times 6 is 18, and then we get 3 zeros. All right. So that's the equilibrium quantity. All right, any questions about this example? Fairly standard. Okay, I was gonna do some group work today, but I think I'm gonna forgo that for the time being so that I can get through a little bit more material. Okay, I promise more group work is coming. But I want to get through exponential functions so that you know how to do your homework. So that is what we're going to do for now. Okay, maybe we'll throw in some group work at the end if we have some time. All right, so new section, we're going to talk about exponential functions. Okay, so every function that we've been talking about so far has been a linear function, right? Or maybe a quadratic function or a polynomial, right? But exponentials are a different type of function. Okay, they're a different type of function where the independent variable appears as an exponent. Okay, so that's why we call them exponential, is because the independent variable appears as an exponent. So independent variable appears in the exponent. Okay, so a common misconception is that a function like x squared is an exponential function. Okay, the function x squared is not exponential because the independent variable here is not appearing in the exponent. Okay, it's appearing in the base. So this is not an exponential, but 2 to the x is something which is an exponential function. Okay, so we're looking for an independent variable to be in the exponent. Okay, so what does it actually look like? So we say p is an exponential function of t if p of t is equal to p naught times a to the t, where p naught and a are real numbers. Okay. So in this particular circumstance, p naught is our original amount, right? Because if we plug in 0 for t, we'd get a to the 0, which is just 1. So we get p0 is our original amount. Okay? A is sometimes called the growth or the decay factor. Okay? And please do note that I use the word factor here and not rate. Okay? We're going to get to rate in a minute. But this is the growth or decay factor. So if a is larger than 0 and smaller than 1, then we have exponential decay. And if a is larger than 1, then we have exponential growth. Exponential growth. And I should add here that a should be a number which is larger than 0. Okay, so I just added that quantifier there. We need a larger than 0. Okay, so what's the deal with exponential functions? Okay, so exponential functions grow in a different kind of way than linear functions. Okay, so for each increase in the independent variable for a linear function, we are going to add a fixed amount, right? That's why when we draw the graph of a linear function, right, it goes up at a fixed amount each time, right? So the graph of it looks like a line, right? Okay, for an exponential function, rather than adding something for each increase in our independent variable, we're going to multiply by something for each increase in our independent variable. Okay, so what does that look like? Well, we can take a look at these tables here, which ask us to identify whether or not this function could be exponential. Now, what we were looking for each time, last time, for a linear function was to check and make sure that the rate of change was consistent, right? That we added the same amount each time per unit difference. In this particular scenario, we're going to check whether or not the ratio is the same between each of our outputs. Okay, as we move forward we don't want to check how much did we plus. We want to check what's the ratio of 18 over 14. What's the ratio of 24 over 18? What's the ratio of 31 over 24? And what is the ratio of 40 over 31? And we want to check, are these the same? Okay? That's how we check whether a function is exponential from looking at its table. Because theoretically, what is this saying? This is saying that p of 1 is going to be equal to p naught times a to the power 1. P of 2 is equal to p naught times a to the power 2. P of 3 is equal to p naught times a to the power 3, and so on and so forth. So what do we want to check? Well, what we want to check is that from each level to the next level, we multiply by a. From each level to the next level, we multiply by a. So first, we need to figure out, what do I multiply 14 by in order to get 18? Well, in this case, if we solve this equation, we get a is equal to 18 over 14, right? Then the next scenario should be that, well, to go from the second to the third, I should multiply by that same number. So let's check. Is 18 times a equal to 24 if a is, as it was previously discovered, 18 over 14? Well, we take 18 times 18, divide by 14, and check, is this equal to 24? My God, I can't do this math in my head. Let's use a calculator. 18 times 18 is 324, divided by 14. We get 23.1428. Okay, so we figured out that if these two things, if these three inputs are to define an exponential function, then we have logically deduced that 23.1428 is equal to 24, which is a contradiction, right? That's not true. So what do we think about whether or not this function is exponential? And we think it's not exponential, because we assumed, okay, if it is exponential, then 23 equals 24, and that's not true, right? So this is not exponential. Okay? Let's see, it's 2:10. Do I have time to do a group? I gotta do interest and finding an equation. Okay, I'm gonna forgo group work for the time being. But I'd recommend you to try these exercises at home. Okay, and we're gonna move on now to the next section, which is one application of exponential functions. Okay, is something that's relevant for all of us, which is interest, right? We put our money in the bank, or we put our money in an investment, or in the stock market, okay? So if you're like buying Dogecoin or buying, I don't know, GameStop or something like that, then this is relevant for you, right? We want to have a good interest rate so that we earn money on our investments. Okay, so an annual interest rate R is the value which governs the exponential function P of t equals P naught times 1 plus r to the power t, where t is number of years. Okay, so let's define what all of these things are. The left-hand side is going to describe, right, my amount of money after t years. The P naught is my original investment. Okay, the R is my investment rate of return, or interest rate. And then 1 plus r is my growth factor. Okay, so as we remember it from earlier, our growth factor was actually our a from our p naught times a to the power t. So in this case, a can easily be found by taking 1 plus r. Okay, so how does this make sense? Well, it makes sense because you imagine what happens to your money in the bank if you have a 0% interest rate. It's not growing. It's not decaying either, right? But it's not growing. Why does that make sense? Well, if we take 0 for our r, then we get p naught times 1 to the power t. Well, if I take 1 to the power 2, or 1 to the power 3, or 1 to the power 4, or 1 to the power whatever, I'm always going to get 1, right? So if I always get 1, then I plug in any amount of time t, I just get p naught, my original investment, times 1. Which gives me just my original investment. So my original investment doesn't change. Okay? So let's see how this works. So, for example, a 5% interest rate corresponds to R equals, well, 5%. Percent means over 100. So we take 5 over 100 and we get 0.05. All right? We get 0.05. All right. I'm getting there here. Okay. Any questions so far about the interest application of exponentials? Okay, let's see a quick example of this. The quick example I'm going to do is technically the warm-up problem. Okay, so we got two banks here. I've gone back to the first page of section 1.5, by the way, if you're keeping track on your notes. So we have $100 to deposit into a savings account, and we have two choices of a bank. The first bank, they say they will put an additional $10 in our bank account per year. Okay, and then if we put our money in the second bank, they will increase our balance by 10% per year, which is what it means to have an interest rate of R equals 0.1, right? So after 1 year, if we think about our bank A situation, we got 2 years, 3 years. Okay, let's make a table. So this is T, and this is P of T, bank A. And then we'll have another column for P of T, bank B. So let's see how this works. Well, when T is 0, we have $100 in both bank accounts, right? No interest has been accrued. But when T is 1, 2, and 3, what happens in bank A? They say they deposit an additional $10 per year into our bank account. That sounds pretty nice. $10 free per year. So after 1 year, we've got $110, and then after another year, we've got $120, and then we've got $130, right? So what happens in bank B? Well, after our first year, what we do is we increase the balance by 10%. Okay, so we take our original 100 and we add to that 0.1 times 100. Now, if we add 0.1 times 100, we can factor out the 100 from both of these terms, okay? And write this as 100 times 1 plus 0.1, which is the same as 100 times 1.1. So we can see actually when we have this increase by 10% per year, what we're really doing is not adding something each year, but multiplying by something each year. So each time we multiply our balance by 1.1. So the first time we go up from, I should compress this somewhat so that I can actually write what the hell we get, which is 110. So after the first year, the two banks perform similarly. But let's see what happens if we take that further. We take 110 times 1.1 again. Then not only do we multiply our original investment by 1.1, but we also earn interest on our interest. So in this case, we get 110 times 1.1, I think it's 121, right? Yeah, 121. So we actually earned $1 more after 2 years. And then we're just going to keep repeating that process. We multiply by 1.1 again. And we get 133.1. So the tricky thing about this is each year we're multiplying by a new number and not adding by a new number. So while in the first bank the rate of change is the same each time, in the second case it's the ratio of the next amount to the previous amount that is staying the same, okay? If I take 110 and divide by 100, I get the same thing as if I take 121 divided by 110. And if I do that, I get the same thing as if I took 133.1 and divided by 121. And so on and so forth. So each time we're not adding a fixed amount, we're multiplying by a fixed amount. Okay, this is called compound interest, right? Versus simple interest is what they call it. But good luck finding a place that will offer you simple interest.
So B would be the best one, correct?
I would say that B would be the best one, just by virtue of we have more money at the end, right?
Yeah.
Yeah. So B would be the best one, I agree. Any questions about this example? All right, but the real power of compound interest doesn't really come from just the first couple of years. Let's say you kept this money in here for 60 years. Well, if you've kept it in here for 60 years, in the first bank you'd have, what, 60 times 10, that's $600 of interest, plus your 100 base, you get $700 total dollars. Anyone want to take a guess on where they think the second option is going to be? Who thinks it's more than $2,000? Who thinks it's more than $10,000? Okay, we'll see. Let's see here. 1.1 to the 60. We multiply that times 100. $30,448. Okay, so pretty big difference over the course of 60 years. Which is why, by the way, if you're like 18 or 19 or I don't know how old you guys are. If you're, younger than 30, that's the best possible time for you to invest in your retirement account. Because having a little bit of money in your retirement account now means a lot of money in your retirement account when you're 65 or 75 or whatever the retirement age is when you guys are old. Okay. So yeah, compound interest is a magical thing. All right, the very last thing I want to talk about here is how to find the equation of an exponential function given 2 points. Oh. And this is I'm all but guaranteeing that this will appear on an exam or on a quiz, okay? So if you pay attention to one thing this class, this would be what I would pay attention to. So the question is, given t1 comma p of t1 and t2 comma p of t2. So 2 points on the graph of an exponential function. We're asked to find out p of t equals p naught times a to the power t. So in particular, we need to find p naught and we need to find a. Then we use a very tricky process here. I'm going to switch colors to blue. We use a very tricky process. Okay? The first thing we notice is that, well, if p of t1 is what am I doing? Yeah, we just plug in t1 and t2 into our original function and we see what we get. So in the first case, we plug in t1. We know that that's equal to p naught times a to the t1. And likewise, we also know that if we plug in t2, all we do is we take our equation p naught a and we plug in t2. Okay? And I'm going to show you a very general process of how we can find out what p naught and what a is. Okay? And here's how it goes. We actually divide the two. Okay? We know if we take p of t2 and we divide by p of t1, then this does something tricky. We start with an equation which we have two equations with two unknowns, and we divide them in such a way that when we rewrite the right-hand side of each of these, we're actually going to be able to cancel our p naught, which is the magical way that we're going to be able to solve this. So, remember, we know what these two numbers are. So the left-hand side is just a number, and the right-hand side becomes a to the t2 minus t1. Okay? If we have a power on a number, that power is in the numerator and in the denominator. If we divide by something to a power, then we subtract that power. Okay, we can rewrite it like that. Okay, and now we have, remember, this left-hand side is just a number. This is just a number. And on the right-hand side, we have our unknown to a number. So the way we get the unknown by itself is, of course, by taking the t2 minus t1th root of the left-hand side. And we divide by t1. And then this is equal to a. So this is how you can find the ratio. Okay? What it basically says is you just ask yourself, well, how do I get from p of t1 to p of t2? I get it by multiplying by a certain number t2 minus t1 times. Okay? That's what the process here is. I understand this is confusing if you haven't seen it before, so don't feel bad if you don't immediately get this. Okay? But let me go on and discuss. Okay, now we have a. So to get p naught, all we do is take a. We know that p of t1, for example, is equal to p naught times a to the power t1. And we know what a is, we know what t1 is, and we know what p of t1 is. So all we have to do to find out what p naught is divide both sides by a to the power t1. So this tells us that p naught is equal to p of t1 divided by a to the power t1. Okay? So you find a by doing this tricky division trick and then taking a t2 minus t1th root of this thing. Okay, and then once we have a, we can back substitute it into one of our original equations to find out what p naught is. Okay, so very tricky trick here. let's see. Okay, I have literally 2 minutes, so I'm going to do an extremely fast example of how this works. Okay, so in this particular example, I've got 2 points. All these suck. I'll just do this one. I've got 2 points. I've got the point 3, 21.6, and I've got the point 0, 100. So what do I know? Actually, in this one, I don't even need to use this technique, but I'm going to do it anyway. No, I'm not. I'm going to just plug in. Okay, I shouldn't do that one. Yeah, okay, I'll do that one. All right. So I know that what? P of 0 equals 100 equals P naught times a to the power 0. And I know that P of 3 equals 21.6 equals P naught times a to the 3. Okay? So what I can do is take 21.6, divide by 100, and that's equal to P naught a to the 0 divided by a to the 3, divided by P naught a to the 0, which is just a cubed. And then I can take the cube root of both sides to get a is equal to the cube root of 21.6 over 100. Once I have this a, all I have to do is back substitute it to find out what P naught is. Okay? All right, I'm out of time now, so y'all are free to go. If you have any lingering questions about this process, you can stay after class. I also have office hours today from 3 to 4:30 on Microsoft Teams. So have a great day, everybody. Hi. Oh, okay. Okay. I can have you, if you have an appointment, I can have you retake the quiz on Tuesday. Would that work? Can you come before or after class?
Yeah, I come before.
Wait, on Tuesday, there was someone in here earlier. Okay, yeah, how about, let's try for before class on Tuesday.
Okay.
And I'm not sure if there'll be somebody in here before us, but I think we can have you take it in time.
Okay, and if not, I'll stay after.
Okay, perfect. Thanks.
Do I think about taking the quiz?
Yeah, so did you transfer into the class or what's going on?
I had mono and like strep.
Oh, yeah, okay. So I'll rewrite a makeup quiz for you, okay?
Okay.
And then can you take it on Tuesday before class?
Yeah. Yeah.
So just come 15 minutes before class.
Okay.
All right.
Gotcha. Thank you.
Yep, no problem.
Yeah, same. I just went home. I emailed like the ombuds, whatever, because they put my dog down last Wednesday.
Oh, I'm
so
sorry.
I went home Monday and they came back Thursday, and they were like, we can't use that as like an excusable absence. So I was like,
Yeah,
okay,
it's
whatever.
fine. You can take a quiz.
Alright.
Just come before class on Tuesday. Does that work?
Right. Yeah, that worked perfectly. I appreciate that, man. Sorry
Yeah.
about that. I should have emailed you, but I was like, they told me it wasn't excusable, so I was like,
Oh, that's okay. Sorry about your dog, man.
No, that's okay. Thank you.
Yep.
I'm not gonna be here next Tuesday. Is
Okay.
there anything specific that I'll miss? Or
No, just watch the lecture on YouTube.
Cool.
I don't really understand I feel like I did this in high school, but I just don't really understand this process
Okay.
right here.
1 second.
Yeah.
Dante, do you have anything?
Oh, no, I'm sorry.
Yeah, I was gonna ask if you could reset one of the homework problems again.
Yes. Can you send me an email?
Sure.
Whichever one it is, just put it in the email and I'll reset it for you.
Sure, thanks.
I want to send an email to reset like 2 of them.
Okay, sure thing.
Thank you.
I just don't really. I remember in high school, it was like A in the 1 plus whatever R to the T. But I just don't remember how to do it when you have 2 points. And I, to be honest, I just didn't really understand like the. It's not that I didn't understand this part as much. I just didn't understand when you were doing like the P of. This just threw me off, like the
Okay.
notation, I guess.
Why don't you sit down? I'll do it on the board.
Okay, cool.
So let's see here. Here's a good example for us to do. Add page. All right. So let's say you start with the points 3, 4 and 5, 64. So using these 2 points, if we want to find the exponential equation which passes through these 2 points, right? What we want is the function p of t, which is an exponential function. So we know that it has the form p naught a to the power t.
Okay.
Okay.
Like
Now,
that's like kind of like a template, like you're just using that for
exactly. This is what it's gonna look like in the end.
Okay.
And our job is to figure out what is p naught and what is a.
Okay.
Okay? So using this equation, all I'm gonna do is I'm gonna plug each of these 2 points into the equation and see what I get. For the first one, where does the 3 go in this equation?
Well, it's the x value. I just don't understand where it would go in that.
Right, but in this case, this is our independent variable.
Oh, so it's time.
What's the independent variable in our case is t, right?
Yeah.
So 3 goes inside the parentheses, right?
Uh-huh.
And then we have p naught, and then a, and then the 3 also goes up here, right?
Yeah.
Okay. And we also know that this is actually equal to a number, right?
That the equation.
Yeah.
Yeah.
If I plug in 3 to this equation, what do I get?
Into which
What number do I get?
which part of the equation? Wait, for all values of. I'm just confused. Like, plug it in where for t?
So I've plugged in t
Yeah.
into this equation.
Okay.
How does the 4 fit in?
That's your output.
Exactly, which is
Just p of a different t, like p of 4.
well, the whole point of this function is it takes an input and it has an output, right?
Right.
If I input 3,
Yeah.
then I do p naught times a to the power 3, and I get 4, right? Because p
How
of
do
t,
you know that?
well, that's how. So it's just a function, right? The way a function's graph works is we take a t value,
Mhm.
we plug it into the function, and that's how we get the height, right?
Yeah.
So in
I
this
get
case,
that.
they give us a t value and they give us a height.
Right.
So we know that we get the height.
Oh.
We get the height 4 by plugging 3 into the
Okay,
equation,
Yeah.
right?
Right.
Okay, we can do the same thing with the other one, right? So 5 and 64, we get another equation. P of 5 equals p naught a to the power 5, which is equal to 64.
Right.
Okay. So now from here on, I'm just going to focus on what's inside this pink box here, really. That's all I'm going to focus on. Because I'm interested in finding out what is P naught and what is A. May I ask, what time does your class start?
Well, your class ends at 2:30, right?
Yeah, is it okay if I stay for 3 more minutes?
Okay, go ahead.
Okay.
You need to set up also.
Yes, thank you. Okay, so we got to finish this up quick. So the goal here is to figure out what is P naught and what is A, right?
Yeah.
And we said that if we take these two equations and divide them by one another, we can get rid of the P naught, right? So let's just do that. I'm going to take the bottom one divided by the top one, okay? So I get 64 divided by 4 on one side. Agree?
Well, how do you know which one to divide by?
It doesn't really matter. But in this case, I like to put the bigger number on top so that I get a whole number instead of a fraction.
Okay, 64. Yeah.
And then what happens on the right-hand side? What do I get?
You get A5 over A3.
Right, P naught A to the 5 over P naught A to the 3, but the P naughts cancel, right?
Yes.
So the left-hand side we can simplify, right? What's 64 divided by 4? It's 16, right?
Yeah, 16.
And then the right-hand side, what do I get?
A to the second.
A to the second power. So how do I find out what A is?
You square both sides, you get 4.
So I get 4, okay. So So now I've got A. Now what was the last step?
Can we choose either one to replug it into?
Yep.
Okay, cool. So I'll do P of 0 times A to the, or 4 to the third. So I get 64, right?
Yep.
64 equals 4. And then you divide by 64 on both sides.
Yep. So we get 4 over 64, which is 1/16.
Is what, 1/16?
Mhm. So now we have A and we have P naught, and we know that P of t is equal to P naught times A to the t. So our end equation is P of t equals what?
P of t equals 1/16 times 4 to the t.
Very good.
Awesome.
You got it.
Great, thank you.
Yep. No problem. All right, I gotta get out of here for the next guy.
It's, so is the quiz next class, does that include the extra problems with the one we just finished?
Yeah.
Like this, okay.
But just email me if you have any questions or come to office hours, okay?
Okay.